Hey all, so welcome back. Uh, let's discuss Codechef 150 starters. Mm, so let's discuss second question, which is ratio by 2. So coming to the problem, so first we'll be given two integers x and y, and you can choose any one of the integer, and either you can increment it by 1 or decrement it by 1. So the thing is, they want us to find the minimum number of operations to get x greater than 2 into y, mm, or um, get y greater than 2 into x. So, well, so the first intuition comes to our mind is um, basically mm, if if suppose they gave us x is greater than 2 into y, right? uh, X that they gave us was greater than 2 into y, or y was greater than 2 into x. In that case, we can just say return 0 because it already satisfied the condition. Let's say it's not the case, right? Let's say it's not the case, and we have x being less than 2 into y, and also we have y is less than 2 into x. So in these both cases, we have to find um, how much should we add to x in order to get it greater than or equal to 2 into y, so that it satisfies this condition. So that will be a task now. Uh, so the thing is that either you can do this, or you can think it in another way. Uh, how much can you subtract from y so that x gets greater? So what do you think will be easier actually in this case? Which one do you think will have the minimum number of operations? Obviously the subtraction part, right? Because even if you like subtract y by 1 or y by 1, let's say, for example, then you're going to like uh, achieve this target value much faster, which is making x greater than or equal to 2 into y. But if you add it, then x is not being multiplied by any integer, so it's just going to take you more number of steps to add up to 2 into y. uh, so in this case, what we can do is, this is the first intuition, so we can say while 2 into y is greater than x, what you can do is you can just keep decrementing your y, right? We can keep decrementing your y. And um and one more thing is we have to handle this case, very similar case, when you can say while 2 into x is greater than y, you can just keep decrementing your x. Yeah, so both of these conditions we will have a check. Also we will have two uh, variables. One is the count one, and can just sorry, can keep it as c1. In this case it's 0, and c2 can initialize c2 also to 0. So the thing here is, c1 will represent the number of steps to decrement the value of y. So you'll just do plus plus every time this while loop runs, and we'll also do c2 plus plus, which will represent the number of times this while loop is running. So finally we can just return the minimum of both of this, which is c1 and c2, in order to get the minimum number of operations. So that's the part. So coming to the code, um, I guess it's pretty much it. I just did whatever I just discussed here. So pretty much the in each case, I just handled that and then just did whatever I was asked to do. So it's a pretty much easy implementable question. So let's move on to the question 3, which is the multi-set question. So in this question, it's actually pretty much easy to understand this question. So here we are given an basically an array, which is an they are giving us an non-decreasing array, which is basically an increasing array. What we have to do at every operation, they have given us k operations. So every k operation, I mean for every ith operation, what we have to do is basically take the minimum as well as the maximum element, add them up, and append it to the end of the array. So in this case, the minimum element is 1, the maximum element is 3. So you append it, you just remove both of them and just append it to the end. So it just gives you 4, right? Similarly, uh, the next iteration it gets to be 1 is minimum, 4 is maximum, remove both of them and add it to 5, right? And finally you get it as 7, and now you can't perform any further operations, right? So this is the basic uh, implementation that they are asking us to do, uh, and they just want us to return the final array after k operation. So a very pretty much easy question. um, so let's see uh, what data structure can we use for this. Going for a brute force approach, maybe you can just brute it. Maybe like can just for every iteration, like in the for loop, we can mm, like sort the array every time. Yeah, we can sort the array and get the first value, which will be the minimum value, and get the max value, which will be the like the highest value. mm, and then you can just remove both of this, just uh, remove this and remove this, and then sum them up. This is 0 and this is n minus 1, and then you can append it to the end of the array dot add sum. Yeah, so this would work, but the thing here is that it's getting you for O of n square approach, which I don't think would be expected for the given constraints um, being mentioned here. So this fails. So what could be a better approach is that maybe we can use an DQ, right? Because you see DQ you can remove from both the ends, right? Either you can remove from this end or you can remove from this end, right? So you will also have an option to kind of pre-compute the maximum and minimum value when using a DQ, especially when you're using a priority queue or something. Um, right. So the thing here is that uh, you see, hmm, whenever you're using a DQ, um, actually, mm, just a minute, I don't think so. Like because, mm, mm, yeah, sorry for that. Uh, so actually, I thought the array wasn't sorted. Like, okay, so the thing is, they gave us the array sorted. So actually, you don't have to worry about, um, if the mm, after every iteration if the array is being sorted or not. You don't have to worry about that because the logic here is like whatever the minimum and the maximum element you take, whenever you add them up, it's going to be higher, right? Because whatever you add to the highest element, it's just going to be higher. So that's the only one logic here. So you don't have to like kind of sort and waste your um, time here. So whatever is the minimum and maximum element, you just sum them up and you can add it to the back of your queue. um, yeah, that's pretty much it. You will do it for n k times, and you just add your sum to the dq, and you just create an iterator to print the value in the dq. So it's also a implementable thing. Now let's go to the fourth question. I was not able to solve it. I just observed it and kind of understood, and I have a very better way of implementing it. So actually, yeah. So what the question actually states is basically we're having an array. For example, let's take the second test case which they gave. Um, right. So the thing here is they want us to choose the elements that are equal in frequency. Like I mean the equal elements. Like in this case, we have one and one equal. We don't have any equal elements for 2, but we have an equal element for 0, right? So in this case, um, yeah, that's one thing. And the next thing that they have stated in question is that um, yeah, you can replace zeros with any arbitrary value, right? It can be any value. That's the next condition they give. And finally they have defined what is an power of an particular array. So to keep it simple, the power of an array is nothing but basically you have to just calculate the the frequency of the elements that are occurring. In this case, we have one appearing two times, and then we have two appearing one time, and then we have zero appearing two times, right? So um, what is the power of this? So in order to do that, uh, we can use combinations formula, which is NC2. In the first part, we have two elements, right? So it's going to be 2C2, the number of ways in which you can choose uh, two elements from two elements, right? So it's just going to be one. There is only one way, right? Either you can take 1 comma 1, that's the only thing. And then the second, it's 1C2, which is not possible. This is just going to give you 0. And in the second case, you have 2C2 again, which is going to give you 1. So this sums up to be 2. So in this case, the power of the array is 2. But thing is, what if we used the operation that they have provided us to do? Like for example, if I try to replace the zeros, for example, I try to replace the zeros by 2, for example, what will be the thing in this case? So for example, 1 is coming 2 times, 2 is coming 3 times, and what is the p value now? It's going to be 2c2 and 3c2. So this will be giving us 1 plus 3c2 is nothing but 3, so it's going to give you 4. So the value is going to be 4. Yeah, so that's the value of p in this case. But is that the maximum value? uh, I don't, right? So what if I try to replace that zeros with 1, for example, and I try to calculate the p? So 1 comes up 4 times, 2 comes up 1 time, so it's going to be 4c2 plus 2, yeah, sorry, 1c2. It's going to be 4c2 is 6, 1c2 is 0, so it's going to be 6. You can see this, right? So you can try any other combination, like you can try to make this as 3, 4, 5, whatever, but anyways you're going to get 6 as your maximum value for power. So why is that happening? It's happening because you can see, right, uh, the more is your value of n, right, the more is your value of n, the higher will be your p. So how can we maximize this n? So the only way to do that is you can convert your zeros to the maximum value or the maximum frequency uh, that is being present in the array, except excluding the zeros, right? That's an important terminology because I've actually missed that during the contest. So the thing here is that we have to calculate the maximum frequency present in the array excluding the zeros. So that's the thing. So uh, so it's very easy to implement here from now. Like how will you implement that in a code? So I'll do that. See, initially you can have a map, right? Not like a map, maybe you can have a frequency array. Let's say the frequency array it's going to start with 0, and also you can see the maximum value of a of I will be like till n, right? This is a very important condition because it helps you come to a conclusion that you can actually form a frequency array, right? So the frequency array would be, in this case, would be 0, 1, 2, 3, 4, 5. So it's 0, 1, 2, 3, 4, 5. This will be our frequency array. So the value of 0 in this case is 2. The value of 2 in this case is 2. Value of 2 is 1. I just updated the frequency from this, right? So this will be the frequency array. This is the values and this is the index. I'm sorry if it's confusing. This is the index and this is the values. So the thing here is you can just these are zeros, right? Yeah. So as we've seen in the code, right? So the first thing we have to do is we have to calculate the maximum frequency. So I will iterate through this frequency array. I is equal to n, I plus plus. I'll iterate through this array and I will get the maximum value of the frequency. Uh, so nothing but max of max comma frequency of I. frequency of array. Yeah. So this will give me the maximum value of frequency that has occurred in this. In this case, the maximum value is mm, 2, right? The maximum value is 2. Also, I want to store the position of this maximum value. So let me just store the position really quick. Uh, so position of this maximum value is actually, it's actually my first index. Yeah, cool. Uh, Now, the thing is, whenever I'm running this frequency, I have to run it from the first index to end, right? Because I want to, I don't want the zeros frequency now, for now. Basically, I just want to know what is the, like I said, like initially, right? I want to count the maximum frequency except the zeros. So I'm just excluding the zero and just counting the rest of it. So that's the part. So after I counted which element has the maximum frequency excluding the zero, I have to replace the frequency of zero, I mean the frequency of that particular position in which I found the maximum element, right? Sorry, the maximum element with adding that with the frequency of zero, basically the count of zeros you have in the array. So once you do that, like in this case, it would be the 2 would be added to here, so it would be 4. Sorry. I mean, the 2 would be added to here, and yeah. So and the value, um, and the value would be 4 here. So the frequency of 1 would change to 4. So that's pretty much it, right? Now you can just maybe you can just iterate again through the array uh, and just count for the values. In this case, we have to just iterate to the array from I is equal to 1 to n, and just do sum plus equal to, which will just keep adding the frequency. This is nothing but the NC2 formula, where you can just update the frequency of I into frequency of I, um, I minus 1 by 2. And finally, you can return your sum. So this is a pseudocode, and it was a very good approach. It's one of the easiest approach. There is actually another approach actually where you have to um, like maybe like you have to add up the count of zeros along with the maximum value, and then you have to again subtract the maximum value from the sum, which I did during the contest, but I failed doing it. Uh, but actually that approach worked, but I just missed the part where I have to exclude the zeros, like I said earlier. So I've not yet implemented that thing in my code, um, but that's the logic um, here. And now the hard question. So this question I haven't read during the contest actually. So actually I haven't solved this. It seemed to be a hmm, uh, seemed to be a good question actually. I can say that. Uh, so the thing is, we have n value and we have n queries. This is the value of n. Then you will be given n queries. So each query will be having a value of x and a value of y. So in this case, 3 2 1 1 4 1 2 4. Yeah. So this is something you will be given. So from this, also you are given an array. Initially the array is 0 0 0 and 0, so it's given something like that. uh, Also the count of zeros initially you will be having is count of zeros initially you will be having is n, okay, because you have n zeros, right? So you can initialize it to 1. And the sum you will be having is 0. Like I said, the sum would be 0. Now we have to we are also given a value. um, yeah, so the thing is we have to perform this operation n times, right? We have to perform all the n queries. So I'm just writing like a, okay. So we'll be running a while loop. So it will be running from 1 to 0 to n minus 1, which is 0 to n, yeah, whatever. Now, what is the first thing that we have to do, right? um, Basically the question here is that, uh, for each or after performing each of the queries, like what this represents is, in the third index we have to change the value of, see, this is the index, okay, x is the index and y is the value. So at the third index we have to change the y to 2, and I mean the x to 2. So in the second operation we have to change the value of index 1 to 1, and in the third operation we have to change the value at 4 to 1 again, and um, at the did I write it correct? I mean 3 to 2 and 1 to, sorry, this is 1, actually this is 1, this should be 0, okay, and 4 to 1 and 2 to 4, 2 to 4, so 0, sorry, 1, this should be 0, actually I have not yet updated. So 4, 2, 1. So this is the order in which you have to like follow up the queries. Yeah, okay. So the thing is, um well, what we can do is, first, like I said, the first thing at every iteration we have to do is you have to decrement the value of 0, right? Basically you have to just play with the frequencies here. So the first thing is you have to decrement the value of count 0 minus minus at every iteration, because you can see, right, every iteration the count of 0 is getting decremented one by one. So that's one thing. So this will give you the mm, number of zeros uh, that you need to change or replace. um, mm, what's next? Next thing is you have to change the frequency of y. So in the frequency array you have to go and change the y by 1. You have to increment the value of frequency of y by 1 in the frequency array. mm, so what else? What else? So next thing is, mm, at every iteration you have to calculate the sum, right? You have to calculate the sum. So whenever you add a value of y to this array, there would be some changes taking place that will contribute to the value of sum. So that particular change, uh, we can explain it in form of an equation. Like for example, if the frequency of y earlier, let's say it was fy, right? If it was fy, at every iteration you're incrementing it by fy plus 1. So basically this will be your new frequency, this is your old frequency at every iteration. So what are the number of pairs that can be formed from this? So here it is Fy by 2, and here it's Fy into Fy minus 1 by 2. So this is your old frequency, right? Old number of pairs that Y was contributing, and this is your new number of pairs that Y is contributing. So the thing here is that in order to update your new number of pairs, you have to completely remove the old number of pairs that Y was contributing, right? Because it will just overlap with the existing value of pairs that Y had, right? That's the logic. So you have to add the new value and you have to remove the old value from the sum or from your answer or whatever. So the sum would be equal to this. So this is at every iteration. Yeah, this will be happening at every iteration. But the thing here is that if you try to simplify this equation, for example, you can see that this Fy by 2 is common. Like if I want to be more clear, you can say that um, yeah, see, first we have Fy minus 1 by 2 and y Fy square minus Fy by 2, and here we have Fy square by 2 plus F by 2, Fy by 2. Yeah, see, this one has an internal subtraction sign, so I'll just bring it inside. So this would become minus and this would become plus. As you can see, these both are complement to each other, so cut them up and you can add the both Fy by 2 and this will give you Fy. So finally we got Fy, right? So instead of just writing this entire equation, you can just write F plus equal to Fy. So this is what is happening every time you add to sum. Yeah, so that's the thing. So you can add sum plus equal to Fy every time, right? Now the next thing is, see, you have actually did the Y part. You know, like um how much is the Y contributing to the sum. You have figured that out. Now the next part is the zeros part, right? The replacement part. So in order to get that, you have to keep a uh, max, which will calculate uh, what is the maximum value. Every time you have to calculate uh, the maximum value of Fy. Why Fy? Because that is the element that we have just introduced, right? That is element that we have just incremented. So you have to check if it's getting your frequency greater or if it's your new current highest frequency, right? So we just update our max and now we can add our sum to be, now this is where the replacement part comes in. You can just take your max and you can make it to be max plus count of 0. This is basically your NC2 formula you can apply to this. So how can you do this? I'll just maybe I can just write like this for now, NC2, right? And you can subtract it with your max element. So this would be returning our answer. So why do I subtracted this? Because you can see that, right? Um, the overlapping issue has happened here also. So the first thing is, when I took the maximum element and count 0, it will calculate the number of pairs um, contributed by both zeros and 1. It is going to be, for example, it's going to contribute this entire thing. Like for example, 4, for in this case we'll have 4, right? So 4c2, so this will give us 6. So this give us 6. But the thing here is that earlier in our sum we have actually added this um, value for 2, which is um, which is basically your mm, maximum value. Like for example 1c0. Okay, this case is fine, this case is fine. What if 0 was 2, right? In that case, in that case if you try to calculate the uh, uh, total value, you can say it's the same 4c2, which is 6. But the thing is, you have actually calculated that earlier, which is 2c1, 2c1. So the sum would have been 2, right? And whenever you like kind of add them with this, you would be getting 8, which is incorrect. Because you see, you have already calculated this and you have to remove this thing that you have uh, calculated earlier. So for that reason, I have to subtract it with the maximum c2, which is your 2 in this case. So 8 minus 2 will give you 6, right? So that's the overlapping issue that I was talking about. So it was quite unclear to me as well, but I just did a few more times and just got an idea of it. So that's basically the idea. And I'll show you my solution. Maybe I can show you that. mm, where was it? Yeah. mm, yeah, so here you can see, for some reason you have to give it in long. I just got some wrong answers because of that too. Some space limit, I guess. I'm not sure about that. So it was pretty much whatever I did, right? So I just took the value of x, and then yeah, and then I took the frequency of y, which is here, and I have incremented that, and then I have maximized my value, and then I just summed up with the f, and then I decrement the value of count here. So everything as I discussed, and finally I've updated the value of my max. So whatever I did was I have subtracted the maximum value and I have added the count 0 plus 1, um, count 0 plus max. So this will give me the pairs that I required after subtracting it from the original existing number of pairs I had. So that's pretty much it. Hope you got the logic. Yep. Thank you.